Hi, this video is about empirical formulas versus molecular formulas. Well, in actuality, it's how to calculate empirical formulas. So let's start on the molecular formula side first. Molecular formulas are those real-life formulas, like H2O is a molecular formula. H2O has an empirical formula, looking to the left, the lowest whole number ratio of elements, to be H2 also. There are 2 H's for every 1 O. This is a 2-to-1 ratio. So, that's not always the same for every compound. So the real-life formula isn't always the same empirical formula. Look below. H2O2 is hydrogen peroxide. Hydrogen peroxide is not the same molecular formula as its empirical formula. It's a 1-to-1 ratio. So to simplify it down, the lowest whole number ratio would be HO, 1-to-1. You could also have something with the empirical formula like CH, and it could lead to many molecular formulas, C2H2 or C3H3. And the bottom one, looking at ionic compounds, they have the same idea too. Ionic compounds, molecular compounds, we can do this same system for either one. So in this video, I'm going to teach you how to calculate the empirical formula. So then once we know that, we can learn how to do the molecular formula. Okay, so I got 2 examples for you here. An experiment determines that a sample of compound contains sodium, Na, oh buggers. Try this again. It contains Na, S, and O. And it wants to know the empirical formula. In other words, it wants to know what numbers go right here. Now, one thing for sure is it won't be Na 39.6, S 27.6, and O 41.3. Not only that it's not a whole numbers, it's also, we can't do a gram to gram. Like 1 gram of sodium, 1 gram of sulfur, they're not interchangeable, because we know that the molar mass of sodium is totally different than the molar mass of sulfur. So when you have something like Na2SO4, it's not that there's 1 gram of Na and 1 gram of S. It doesn't work that way. We can't use grams for the units here. So this doesn't work. But what we can say is moles. Like if you did have something with Na2SO4, or Na2SO3, or Na2S2O3, any of these could be possibilities for this here. We can say that for every 1 Na, you have 1 sulfur, if it's a 1-to-1. Or you could say that you have 1 mole of Na to 1 mole of sulfur. So our first stage here isn't to have it in grams. It's to convert those grams into moles. So I'm going to prep for that. 27.6 grams of sulfur, 41.3 grams of oxygen. My step 1 is to convert to moles, because that'll tell me the ratio in my empirical formula, in a mole ratio, and that's what it is. So in order to convert from grams to moles, I'm going to need that periodic table number for each substance. You can see I'm doing it for each problem because they do get a little lengthy, these problems. I know for every 1 mole, they have a different periodic table number, so that's what I got to look up. The grams would be 22.99 for sodium, sulfur is 32.06, and oxygen is 16.00. I did all the calculating ahead of time, so you can double check me if you want. I don't know if it's worth your time. I would just kind of trust me. That way it'll save you time in the video here. 1.722488. That's how many moles I got of sodium. Notice I didn't do sig figs because it doesn't really matter. I got to get to a whole number, and that's not a whole number, so I'm not done yet. 0.860886, and for the oxygen is 2.58125. Okay, so that's how many moles I've got. So I actually can say I've got Na 1.7-ish, S 0.86-ish, and O 2.58-ish. Those are not whole number ratios, but they are ratios. I can say that the sodium to sulfur oxygen ratios are these numbers. Now in empirical formulas we need whole numbers though. So in order to get a whole number, I'm going to find the smallest number and divide all of them by that. That would give me the whole number fractions. So here's my smallest number, and my step 2 is to divide by that smallest. So I'm going to take all of them and divide by that 0.860886. Which here is, of course, 1. 0.860886. This top one is going to be 2.00, which was going to round me to 2. And the bottom, 0.860886, is going to give me 2.99er, which is really going to round to 3. My third step, I kind of did it as we went here, is to round to that nearest whole number. So now I really do have Na2 to S1O3. Sodium sulfite. That's my empirical formula. So far, so good. Let's go to a little bit trickier one here. Okay. I've got a sample of vanadium metal, and it's heated, and all of it reacts with oxygen, that must be the out part, to create a compound containing vanadium oxygen. It has a total mass of 0.633 grams. Now it also told me that vanadium is the 0.345 grams. So if I want to know how much oxygen I have, I'm going to take that 0.633 and subtract from it 0.345 to get a whopping 0.288 grams of oxygen. Okay. I've got vanadium, oxygen, I've got 0.345 grams of vanadium, and 0.288 grams of oxygen. Step 1, convert to moles. So here I'm going to multiply, put grams on the bottom, and moles on top. 1 mole on top. My grams number, oxygen again, is 16. Vanadium is actually number 23 in the periodic table and is 50.94. If I divide these out, I get 0.00677, and my oxygen is 0.018. Second step, I'm going to divide by the smallest number. So this one is smaller. I'll divide by the 0.00677 to get 1 here. 0.00677 to get 2.66. Now, that's not very close to 3. I mean, clearly you would round to 3, but that's actually not so great. 2.6 rounded to 3 is kind of a pretty big round. So let's think of things a little bit differently. Because the step 3 is really going to be a round or multiply. So here, when do I actually multiply? That 2.66 it ended in is kind of like this last block over here. 2.6, this is really like 2 2/3. And if I had a fraction that's 2 2/3 and I want to get to a whole number ratio, I'm going to multiply it by 3. Or if I ended in 0.5, I'm going to multiply it by 2, because 0.5 is like half. Or if it ends in 0.25, that's like a quarter, or 0.75 is like 3/4, so I'm going to have to multiply it by 4 to get that to work out. Okay, so going back here to our picture, I'm on step 3. Step 3 in the last one was round, or, like we see in this one, we're going to have to multiply. Now it is, I mean, there's many fractions this could be. I picked 3 of the most common to multiply by 4, 3, or 2. I think it'll stick to something pretty, systematic, pretty obvious on what you should do. And if it doesn't, maybe you want to check your math and then retry again. But if it's looking that way, then you've got to do the best you can. Should you round or should you multiply? What kind of fraction do you have? And that'll be your best guess. But in this case, this 2 and 0.66 is like 2 2/3. So I'm going to multiply this by 3. And what you do to this one, you have to do the top one to find the lowest whole number ratio. So here, 2 2/3 is going to get me to 8. Let me multiply by 3. And the vanadium is going to be a 3, because I multiplied 1 by 3. So I've got V3O8 as my empirical formula. So these are the 3 big steps for doing it. Hopefully this kind of gets you started and you'll be all right to go. You can try textbook problems and let me know if you've got questions from here.